Hello everyone. Today we will discuss the topic on introduction to crop simulation models. First we can see the what is meaning or definition of model, modeling and simulation. You can see the first one model. Model is a simplified representation of the system or the process. Also the model construct the conceptual framework that describe the system means whatever the systems are developed or designed that is needed for to solve the problems whatever the problems are occurred in the system. For example, in the agriculture system there were use the simulation model. In that model there is a mathematic or the mathematics part, then the statistical part and the computer system which are integrated and to design the simulation model which is used for specifically to solve the problems in the system in agriculture from start from the planting and till to harvesting the crop. Then next one we can see the modeling is based on the assumption that any given process can be expressed in the formal of the mathematics statements or the set of statements. That the concept of modeling are the part of the mathematics statements where the different mathematical ways or the different uh, variables or the non-variables methods are used to solve the problems in the system. Then also modeling is also defined as the application of methods to analyze the complex real world problems in order to make the predictions about what might happen with various actions. This in this case of the modeling, the different methods are to be used. That is, for example, mathematics method, statistical method, and the combinedly the through the help of or with the help of computer we have to analyze the system whatever the complexity are occurred to also use to solve the problems in the real words helps to make the predictions or the proper results. Then simulation is the operation of the real world process of the system over the time. In this system the computer, then statistic and mathematicals are the uh, three ways are integrated which have to apply in the system for the solve the problems of the system. Then simulation means the simply process of building models and analysis the system. We have to develop the model that is will be integrated with computer, statistic and mathematics for the analysis of the system. Then also called simulation, the technique for studying the real world dynamic system. Mean whatever the changes occurred in the system, we have to study first. That technique are also used for to reduce the behavior changes by using the mathematical model. Then also implemented on the with the help of digital computer. Means in short, the simulation is the study of real world dynamic system or to solve the problems in real world with the help of or by using the mathematical model or with the help of the statistical model and combinedly implemented both mathematics and statistics on the digital computer. That's the concept of the simulation. Then also simulation is also defined as the numerical technique for solving the complicated probability models. Complicated probability means whatever the chances occur in the system to solve the problems should be analyzed with the help of different mathematical equations, that is the partial equation and differential equations which are used on the way of or by the way of computer to analyze the complicated functions in the system. Then we can see next one the computer simulation, a powerful method or methodology to design for the analysis of the complex system. With the help of the computer, we have to use the mathematical model and the statistic model combinedly or which can be integrated when they joined to the computer system, helps to solve the problems with the help of uh, modeling or with the help of simulation. Then overall approach in computer simulation is to represent dynamic characteristics of the real world system to a computer model. Then crop model. Next one, the crop model is a simple representation of the crop. For example, the crop ideotype. This is a biological model where the crops are designed or the models are designed. Whatever the new approaches or new techniques are coming to increase the potential of the crop by uh, proper way to represent the crop or to show the crop with the help of different techniques to be followed for getting the higher yield. That's the concept of crop ideotype. There are different types: market ideotype, or the stress ideotype, or the climate ideotype, or the biological ideotype, or the plant ideotype. The ideotype concept was first developed by the Donald scientist, just like the crop model, which represent the crop. Then also the crop models are tool of system in research with the help of the solving problems related to the crop production. Means the in this system, the you have to apply the research or you have to conduct the research. With the help of that research or the particular research, we have to solve the problems, whatever the problems are related in crop production, start from sowing to harvesting. Next one, the classification of simulation. The simulation can be classified in two ways. That is, first one, continuous simulation, and the second one, the discrete simulation. uh, Discrete simulation, in this case, continuous simulation, the state variables means that is a collection of variables needed to describe the system, which can be changed continuously over the time. And also the continuous change the behavior of the system is typically described by or with the help of differential equations. Means in this simulation, the different mathematical part, that is differential equations, are used to carry out the changes continuously over time and to check out also the behavior of the system. That is a continuous simulation. In continuous simulation, for example, the modeling of the thermal or hydraulic system are the ideal example of continuous simulation. Then discrete simulation are the driven where the state variables change at a discrete time point. Means discrete means the discontinuous simulation. There is the variables or the state of variables are changed accordingly in a discontinuous way over time. And the example of this discrete simulation are the industry applications and the whatever the manufacturing applications which are coming under discrete simulation. Next one, we can see when to use the simulation. Simulation can be used where the integral or internal complex systems are followed, especially in biology system. Then optimized existing design. For example, the routing algorithms, the assembly lines where the simulation can be used to examine the effect of environmental changes, whatever the environmental changes, that is global warming or the weather forecasting or the effect of temperature or any other climatic factors, we have to examine with the help of simulation. Then also whatever the system is dangerous or descriptive is happening, for example atom bomb, atom reactor or missile launching, where to use the simulation. Then also the you have to study the importance of variables, that time also you can use simulation. Then also the test of design policies or the new policies where the use of simulation. Then major use of the simulation is to analyze the variability of system or the complexity of the system. Then also use in especially in agriculture, the system or the simulation can be used to solve the problems in starting from planting to harvesting of the crops, as well as the different management practices, the production practices where they use the simulation. Then next, when simulation is appropriate when it will be interact with the subsystem with the complex system, whatever the subsystems are there. For example, in the simulation model, static model, mechanistic model, then deterministic model or descriptive model. These are the subsystems of the simulation or the model which we are interact with the complex system. Complex system is where the problems are occurred in that system. Then informal or organization or environmental changes can be simulated and find out their effects when there is the simulation is appropriate. Whatever the informational, organizational or environmental changes can be simulated or can be analyzed with the help of their systematic simulation model. The simulation model also helps to gain the knowledge about the system regarding the improvement. Also find out the parameters for changing the simulation inputs. Also design the policies regarding the implementation. Then also the different capabilities of the machine can helps to determine the requirement. Simulation model designed for especially training the learnings possible without cost descriptions, and also the visualize the uh, animated simulation. These are the different ways of when the simulation is appropriate. When the simulation is not appropriate, the problems can be solved by common sense. Then there is no simulation is not appropriate. When the problems can be solved analytically, when there is no simulation is not appropriate. If it is easier to perform direct experiment, there is no need or application of the simulation. If the cost exceeds saving or exceed than the saving, then that time simulation is not appropriate. If the resource or the time are not available, that time also simulation is not appropriate. If the system behavior is too complex, like the human behavior, the simulation is also that time is not appropriate. Then next one we can see the objectives of simulation modeling. Major objective of simulation model is to find out adequate parameter before implementation, to predict the effect of changes, or to solve the questions regarding the problems occurred in real world system. Also to check out the potential changes in the system, and also promote the use of system for the analysis of problems, and to also assimilate knowledge gained from the field experimentation, and also offer dynamic quantitative tool for analysis of the complexity or the problems are occurred in the different cropping systems, and also simulate the uh, problems whatever the occurred in the new systems which are designed. It may be in organization or in case of the educational or in case of manufacturing industry or in the different sectors where the simulation model is used. Then types of model, there are different types of model. First one statistical model, second one mechanistic model, third one deterministic model, fourth one stochastic model, for next one the dynamic, and then static model, simulation model, descriptive model, and explanatory model. Then first we can see the statistical model. In this model, the especially explain in the relationship between the yield or yield components with respect to the weather parameters, where there is a statistical model are used to check out the yield of the crop or yield variation of the crop with respect to different components of the yield, and the compared with the whatever the weather parameters are there, that is for example temperature, humidity, cloud, then wind direction, then rainfall are the parameters which will be compared or you should be analyzed with respect of the yield of the crop, and these relations can be expressed by the statistical or can be measured by using the statistical techniques. For example, regressions, correlations are the important statistical methods can be used to check out the or express or explain the relationship between yield of the crop versus the weather parameter. Second type of model, that is mechanistic model. These models explain the relationship between weather parameters as well as yield, as well as the mechanism of these models are occurred especially in the different parts or different categories or different relationships or the variables. These models based on the physical selection, that is a mechanistic model are only to check out the relationship between the weather parameters and its yield of the specific crop versus the what is the mechanism behind this reducing or increasing the yield. That time you have to use a mechanistic model. Then third one, deterministic model. These models estimate the exact value of the yield or the level of yield. These models can have also defined the coefficients or different types of efficiencies or should be used or to determine with the help of this deterministic model. Then next one, the stochastic model. In this model, the probability element is attached to each output. That is, may be chances, it may be low or high or medium for each set of inputs. Whatever the inputs are applied for the agriculture system, you have to relationship between the whatever the outputs are occurred, which should be the ideal example of the probabilities. And these models, these stochastic model are defined for only to determine the yield variability in a given period of time or given rate of time. Next one, the dynamic model. This is a in this model the time is included as variable. Both dependent as well as independent variables are having values which remain constant over a given period of time. Next one, the static model. The time is not included in this case. Then dependent non-dependent variables having values remain constant. That is, static means the constant values are occur with the respect of dependent and non-dependent variables over a given period of time. Then simulation model. In this system, the model where the computer systems, mathematical system and the statistical systems which are integrated for or to represent the real world system. The main goal of this crop simulation model is to estimate the agriculture production with the function of weather, soil conditions as well as the crop management. And these models are generally used to solve the problems in the agriculture system or to calculate both rate and state variables over time from starting from the planting until harvest maturity or final harvest of the crop with the help of or by using the different differential equations, that is mathematical way, statistical way, and which can be integrated or combinedly to the computer system. This is the integrated system which can be used for the analysis of the problems of the agriculture system. This is a major scientific model which can be used in agriculture. Then descriptive model. A descriptive model defines the behavior of the system in a simple manner. This model which can be use the different types of mathematical equations. For example, equation in derived form or the different uh, quickly determining the for example weight of the crop or the yield of the crop. We have to use the differential equations or the uh, s- uh, derived equations can be used for the analysis of the problems. Then explanatory model. In this case, the quantitative description of the mechanism and the processes that cause the behavior of the system, which can be analyzed with the help of the descriptions of the entire system by proper way, and also the leaf area, for example in leaf area expansion, tiller production, crop growth can be analyzed with the help of the experimentary model. Next one, the advantage of the simulation modeling. The major advantage of simulation model is to operating in the new policies or new procedures or the new hardware design, physical layouts, transportation system where the simulation model can be used, or the simulation model can also be used to find out the problems occurred in the agriculture systems. Then also uh, this is a major part of the understanding how the system operate, how if questions can be answered with the help of these simulation modeling. Then what are the disadvantages of simulation modeling? Building requires the special training. This is a major disadvantage. Then also requires these simulation softwares which can be developed by the accordingly packages of the inputs. Then also requires can be results the difficult to interpretation or the manipulation of data. Simulation modeling and the analysis can be time consuming and expensive. The many simulation softwares have the output analysis. These are the major disadvantage of the simulation. That is, first one requires special training, requires the software packages or develop the software package, then requires different output analysis data, then also difficult to interpretation of data, then also requires more time, and the cost of model or this input is also, or software is also is more. Next one, the development of model. In this case, the weather data includes, crop data includes, crop management data, pest data, and these are the major part of the data are required to develop the crop model. In case of weather data, the maximum minimum temperature, rainfall, relative humidity, solar radiation, wind speed are to be considered for development of the crop model. The crop data includes mainly the name of crop, variety of crop, phonology means the morphology, day to analysis, day to maturity, then whatever the changes occurred in the crop start from sowing to harvesting, that the concept of the crop phonology. Leaf area index also, grain yield, above ground biomass, then 1000 grain weight. The soil data includes also the part of the development of crop model. There is thickness of soil layer, pH, EC, and pK, organic carbon, soil texture, sand and clay percentage, moisture percentage, field capacity, wilting point, as well as bulk density. In case of the crop management data includes the date of sowing, then from start of a simulation you can use the transplantation date of rice, then need of the fertilizer, irrigation, manure, residues application, or the for input application. Also the study the CN ratio of the applied organic nutrients, especially in crop management data. You have to uh, use the date of sowing, date of planting, or the depth of sowing, spacing, then the different seed rates of the crops are to be considered for development of the crop model. Then pest data include name of and type of pest, their mode of attack, pest population of the different crop growth stages. Accordingly, data of the pest or insects could be only those models which can be pest module are should be considered. Then the what are the steps in modeling? The major steps are define goals. Accordingly, goals we can develop the model or this model for the solve the complexity of the system, especially in agriculture system. Various disciplines are there in order to develop or understand the crop model, where the strong knowledge of the basic subjects depending on the objectives of study, knowledge of their different disciplines should be integrated to develop the crop model. Means in short, we have to develop the crop model for required for the details knowledge about the different disciplines which can be integrated for the development of the crop model. Then define system and its boundaries. You have to finalize or define the system in, especially in agriculture, crop field is chosen as the system is to be finalized. Then also define the key variables in the system, whatever the variable key variability is there, state, rate, driving, auxiliary variables, and the state variables can be measured or quantified. For example, the soil moisture content, crop yield are to be used as the key variables for the development of the crop model. Then quantify relationships. In this case, the different mathematical equations and functions are used to quantify the results of the crop model. Then calibration of the data. When the model is developed or crop model is developed, it requires calibration and validation. First of all, it run the model with the help of the experiment and calibrate accordingly. This is the today's topic of the introduction of the model, types of the model, modeling, simulation, types of the simulation, what where the when the simulation is appropriate, when the simulation is not appropriate, advantages of simulation, disadvantages of simulation, then what is the steps of model and the development of model. Thank you.